Good evening. Namaste. Hare Krishna. How are you?
Sir, I'm fine.
And your homework is complete, right?
Yes, sir.
So try this question in the starting. You have to change it into P by Q form in two different ways, long cut and shortcut both. Okay? So do it and submit. Do the long cut only. Long cut only.
Excuse me, sir.
Yes.
Sir, is the bar sign on 2 or in 5 or 2?
Bar sign is over 5 and 2.
Okay.
5 and 2.
Sir, I have sent.
Sent. Okay.
Yes, sir.
Whose answer is this?
Sir, Samaira.
Samaira.
Sir, I have also sent.
You got 35 by 9. But it's 0.353535. 35 by 99. When I divided 35 by 99, I got 0.353535. So it's actually 35 bar. 35 by 99 is equal to 0.35 and a bar sign over it. Not this one. We need to check what went wrong. Let us see. First step, take this equal to x, 0.00352, and 52 has bar sign over it. It may be repeating 52, 52, 52, and so on. With what number we should multiply here? You have multiplied with 100. Okay. 100 will do. I am also multiplying with 100 only. So 100x is equal to, decimal will come here. So decimal 3, 5, 2, 5, 2, 5, 2. Our motto, we have multiplied with 100. I told you in the previous class, we can choose some other number also. But on what basis? Actually, the basis is very simple. We want to have the same digits in the same vertical column. 5, 2, 5, 2. Can you see this repeating in the vertical column? 5, 2, 5, 2.
Yes, sir.
Just we want, when we subtract it, it should be 0, 0, 0, 0, 0, 0. That's what we need to make up. Our plan should be based upon. This is the first equation. This is the second equation. From second minus first. Second minus first gives 99x here on the left, and on the right side 0 will be after this until this. 12 minus 3, 9, and this is 4 minus 0, 4, this is 3. I am getting 0.349. Is that okay? Check it.
Yes.
If it is not comfortable, I will show it in a different way. So x is going to be 0.349 divided by 99. Now a 3-digit decimal on the numerator shows, if we remove decimal from numerator, we'll have 3 zeros in denominator. So 349 divided by 99 and then 3 zeros over it, so 99,000.
1,000.
If you think we can cancel out, we will, else we leave it here only. I leave it here only and the answer is done. Now let us check it once again with the help of calculator if it gives the required number. $349 divided by 99,000. 349 divided by 99,000. 99,000 equal. You can see the result is same. The same number came, 0.003, then 52, 52, 52, 52, 52.
Yes, sir.
So I see here you have written first equation correctly. Actually, in the first equation, you need an improvement. Ahana wrote it better. When you make an equation, don't use bar sign over it. Instead, expand it. Expanded form would be better like this. Why so? Because when we subtract equations, we want zeros. That's why. So better is to write in expanded form. Here,
Okay, sir.
correction is required in the first equation, in the second as well. The main problem happened here in the subtraction part, and this part is wrong in both of your calculations, Ahana and Samay. So be more careful when handling these calculations.
Okay,
Okay.
sir.
Any questions?
No, sir.
Let's try one or two more of the same type. Which book has been recommended by your school?
NCRT, and there is another book, Standard Math.
NCERT and Standard Math. What's the writer's name?
Yes, sir. ML Agarwal.
Sorry, repeat.
Sir, ML Agarwal.
ML. Okay. NCERT and ML Agrawal. Can you please confirm one thing? Look at your book, NCERT and ML Agrawal, both books. Check if anything mentioned on it, like new education policy, NEP type, anything on the cover page, or
1 second, I'll see.
yes, please check.
No, sir.
No?
Yes.
If not mentioned on the cover page, please check in the second or third page in the preface page, if it is mentioned somewhere, NEP, or in the full form, new education policy, etc.
No, sir.
No? Okay, no problem. Actually, I wanted to confirm the government has applied NEP now from this year onwards, new education policy, according to which everyone is expecting some change in the teaching method, or I don't know, I'm not sure very much in the content. Some people are expecting some change. This is what I wanted to confirm, if you have any change in there. If there is any, then I'll accommodate this. Okay, if that is not, no problem. Let's continue with our topic. Do this one now.
Okay,
0.47 and bar sign is over 7.
Sir, I have sent.
Okay, just a moment. Both of you are done?
Yes, sir.
Okay. Different answers. Whose answer is the first one?
Sir, Ahana.
First one is from Ahana. Second one, Samaira. Samaira got 4 by 9. Ahana got 43 by 9. Different answers. Well, since you have different answers, so I would like to show it here. Let's take x is equal to 0.4777 and so on as the first equation, and let us multiply with 10. 10x is equal to, since only 1 0 we have multiplied here, so one digit will come on the left side of decimal, 4.77777 and so on till infinity. That's our second equation. From second minus first, 10x minus x is 9x on the left side. On the right side, this digit onwards everything will be 0, but here 7 minus 4 is 3 and it's 4, so 4.3. X is equal to 4.3 by 9. If we remove decimal from the numerator, we get 43 by 90. Both of you have made mistakes. We can check it, cross check it with the help of calculator. Ahana, your answer is 43 by 9. Let us divide 43 by 9. 43 by 9. And the answer is 4.7777. That's a different number. The given number was 0.47777, but it's different. Now, Samara, your answer is 4 by 9. Let's see, 4 divided by 9. 0.44444. Still not same number. Now let us divide 43 by 90. 43 divided by 90. 43 by 90 gives 0.4 and then 7777. The same number here. So what went wrong this time? Now I see you have written the first equation itself wrong. You have written, Ahana, 4.77 for x. X is equal to 4.77. That's wrong. It was 0.4 then 77. You have taken 4 on the left side. That's wrong. And here x is equal to 0.477. Okay. 4.77. Samaira, your first equation and second equation both are correct. And here 10x minus x is 9x. 4.47. Oh no. No, second equation is wrong here, Samaira. See, when you have multiplied with 10, 4 came on the left side, right? But another 4 you have written on the right side as well. Did you notice the mistake?
Yes.
When you multiplied with 10, due to 1 0, 4 went to the left side of decimal. That's okay.
Yes.
But another 4 you have written on the right side also. That is extra, and that's wrong. And Ahana, did you get your mistake?
Yes.
Instead writing 0.4 then 777, you have written 4.777, different number. Be careful. So why is it going wrong? This was the second time. You are getting nervous while doing the question. Don't worry. Let's go through the next one. Let us try one more. Change 23.4373, and 73 has a bar sign into the form P by Q. Now try this one and submit. Are you done? Okay, no
Yes, sir,
worries.
I'm
Take your
done.
time. Take your time. Are you done now?
Yes. Sir, we both have.
Whose answer is this?
Sir, Ahanas.
I have to ask it again and again. Right? Ahana. And the another one from Samaira. This time both of you were having packed. Answers are matching this time. You thought every time answers are different. This time we will make it happen together. Good. Let us check with the help of a calculator.
Sir, can I send the answer once again?
Sorry.
So can I send the answer once again?
2320 by 99. 23.434343. It's coming different again.
Yes,
See the result?
sir.
It's 23.43434343, but the number was 4373. 73 should have been repeated. Well,
Yes.
something went wrong again. 23.437373. X is equal to 23.437373. First equation is correct.
Sir, I did some subtraction mistake.
Okay.
Sir, I have
You,
sent.
both of you found your mistakes, Samaira,
Yes.
Ahana? Oh,
Yes.
okay.
Sir,
Okay. Let us see here. So let x is equal to 23.43, then 737373 and so on. This is our first equation. Now since we have two digits with the bar sign, so let's multiply with 100 this time. 100x. If we multiply with 100x, we have to take two digits to the left side, so it will be 2343 on the left side here. 2343 and then decimal and then 737373.
Yes.
Second equation. Now we have to subtract first from second. From 2 minus 1. From 2 minus 1. So on the left side, 100x minus x is 99x. Okay, let us write it in the arranged manner, vertical manner. 100x is equal to 2343.737373 and so on. Below it, the first equation, x equals 23.437373 and so on. If we subtract, we get here 99x. Decimal here. This digit onwards will be everything 0. 7 minus 4 is 3. 3 minus 3, 0. 4 minus 2 is 2. 2, 3. So 2320.3. And I guess here is the mistake in your calculation, right?
Yes.
So x is equal to 2320.3 divided by 99. Remove decimal from numerator, put 0 in the denominator. 23203 divided by 990. If it is possible to cancel out, we will, else this is the answer. Now let us cross check it again with the help of calculator. Calculator is not allowed in exam, so we are using it just for confirmation. 23203. Here is the number divided by 990. And see the result is here 23.43, then 737373. Exactly same number came that we had here. Okay, this was the third question of this type. So your focus, I'm noticing that you have caught the process, the method. So that's not a problem for you. Understanding is not a problem for you. Your problem is focus. While performing a calculation, while performing work, you get nervous, I guess. And in nervousness, you make these mistakes. So just focus over your work and try your best. Well, can we now move ahead at leaving this?
Yes.
So let us try this one using the shortcut method. Do you have the idea? I taught this in the previous class. Do you remember what was the shortcut to do this question? No? We'll do the same question again using shortcut. Okay, you have forgot. Let me remind. First number after removing decimal and bar sign. Remove decimal and bar sign. Whatever is remaining, write here. What is that?
So 43 4.
23,000. Sorry, 2,34,373. 23, 43, 73. Right? After removing decimal and bar sign, whatever remains, we write it. Okay.
Yes.
After minus sign, now we have to subtract a number that is found by taking the digits without bar sign, without decimal, without bar sign and without decimal. What is the number?
43.
Not just 43, without bar sign.
23.
2343.
Yes.
Whatever is there without bar sign and without decimal, I mean remove decimal and remove those digits with bar sign. Remove decimal and remove those digits also which are having bar sign. Then 2343 are remaining. Any problem?
No, sir.
In the denominator, write 9 as many times as digits with bar sign. How many?
2.
2 nines. Write 9 2 times. Now see how many digits on the right side of decimal without bar sign. On the right side of decimal without bar sign.
43.
2 digits. So we have to put 2 zeros here. Done. Now do the calculation and you'll get the result. 3 minus 3, 0. 7 minus 4, 3. 3 minus 3, 0. 4 minus 2, 2. And then 2, 3. Is that right?
Yes, sir.
Divided by 9900. Can we cancel out 1 zeros?
Yes.
So 23203 divided by 990. Is that the same answer we got previously?
Yes.
Yes, that's the same answer. And that's the shortcut. Shortcut can be used in case if you have a multiple choice question. As per NEP, National New Education Policy, you might have seen in your previous exams as well, due to pandemic, CBSE board preferred giving some MCQs in your exams. I guess 10 or 20. How many?
Sir, we had 25 MCQs and 25 longer.
25. So now it's a trend. Notice that now it's a trend. You will be getting MCQs as well. So you should be ready with this type of shortcuts whenever, wherever possible, you should apply it. It will save your time. Because if the same question comes in MCQ, you won't get more than 1 mark. No matter if you do the same question in the long answer type question, descriptive type answer, you may get 2 or 3 marks. But if the same question comes in MCQ, you won't get more than 1. It's just 1. So save your time. That's why you should remember. Previously, we discussed about addition and subtraction of irrational numbers. Like having root sign, I mean. Actually, these are called radicals. In mathematics, these are called radicals. What is mean by radicals? Let us see it in more detail. Radicals, numbers written inside a root sign, but there is no way to remove the root sign out of that. For example, let us consider this and this. See these two. In the first example, you can remove the root sign writing its value like this. But this one, you cannot remove root sign and having a whole number. It's not possible. Root 3 is not equal to any whole number. So you have to carry it in the same way. It's an irrational number actually. And this is what we call radical. In mathematics, this is radical. Radical. So radical are those expressions with root sign which cannot be removed completely. Expressions or numbers with root sign that cannot be removed. Are radicals. Now let us learn more about radicals, how to handle, because this type of expressions may be asked in your exam, maybe in your textbook as well. So suppose there is a root sign. Let us take it a bigger way. Notice how many numbers remain involved in a radical. 3 numbers. One number here in the V shape, and the rest of the 2 numbers are here inside the root sign, one in the base, another in the power. Total 3 numbers. How can we represent it in another way without root sign? Of course, we cannot remove root sign in radicals, but there is a way to represent. There is another way of presentation. See how. The base number A is written in the base itself. The power m is still in the power, but this number n, which is in V shape here, is written in the denominator of the power, like this. This means this, a raised to the power m by n. Is that complicated? Is that complicated? No, simple to understand. Let's take some example, like you are having cube root 3 there in place of n, and suppose you have 7 raised to the power 2. What do you think we can write for it?
7 raised 2 by 3.
Correct. 7 raised to the power 2 by 3. Perfect. So in specific, specifically, if n is 2, then root is called square root. Then the root is called square root. If n is equal to 3, then the root is called cube root, like this one, this example.
Yes.
N is 3. If n is 4, we call it fourth root. Fourth root, then fifth root, sixth root, seventh root, etc. So these are the series. This is how we call them. And there is one more specific information. In case n is equal to 2, we write nothing. 2 remains by default hidden. For example, you simply write this. What does that mean? That is actually a square root, and 2 is hidden here in the V shape. 2 remains hidden by default. But if any other number, you can't keep it hidden. If it's 2, you can keep it hidden. It's your choice. But except 2, any other number can't be there hidden. Note, 2 remains hidden in square root. So we never write 2 if we have to write a square root 2, a square root 4, square root anything. Like square root 2, 2 is hidden here. In this place, in the V shape, 2 is hidden. But if we have to write cube root, we can't keep 3 hidden. If we have to write cube root of 2, then we have to write 3 here. It's must. We can't keep it hidden. Is that clear? Okay. So now the next rule, next thing we are going to discuss is how to operate such irrational numbers, radicals I mean. How to operate means mathematical operations I am talking about, addition, subtraction, multiplication and division. So if we have many radicals, especially with the same n value, how to add, subtract, multiply and divide. Operations on radicals with same n value, like both of them may be a square root, both of them may be cube root, both of them may be fourth root, etc., whatever, but same n value. See how to. Different radicals are treated as different variables while adding or subtracting. For example, if you have root 2 plus 3 root 2, you have the same radical.
Yes.
N value same. Number inside the root sign, I mean the base number, is also same. The number inside this root sign is also same. So they are called same radical. We can add them like x plus 3x. Just like them. X plus 3x, we write 4x. Similarly, root 2 plus 3 root 2 will make 4 root 2. Same as variable, not different treatment. If it is a minus sign, we'll treat in the similar manner. Like x minus 3x will be minus 2x. So root 2 minus 3 root 2 will be minus 2 root 2. If we have 2 root 3 plus 5 root 3. Notice radical is same. I am not talking about the multiple, the coefficient. I am talking about radical part. If radical part is same, we will treat them as same variable, like 2x plus 5x. It will be 7x. Similarly, it's going to be 7 root 3. 7 root 3. So simple to add and subtract. But if we have different radicals, we can't operate. Like 2 root 3 plus 3 root 2. Now they are different radicals. N value is of course same, but number inside the root sign is different. So they are treated as different radicals. Either n value is different, there will be different radicals, or number inside the root sign are different, there will be different radical. Okay, no matter which one, but any one of the two, either n value or the number inside the square root, any of them is different, it is different radical. Different radicals can't be operated. We cannot operate. So we leave it as it is. This expression is already simplified. We cannot make it more simple. This was possible to simplify, like root 2 plus 3 root 2. If we simplify, we get 4 root 2. It was possible to combine together to simplify, but this further cannot be simplified, so we stop here itself. If you are handling any question and suppose you get this expression at the end, you have to stop there only, because nothing can be done after this. This was about addition and subtraction. Let us see now how to multiply and divide. Multiplication of radicals. Radicals are multiplied using laws of exponents. You might have studied laws of exponent in grade 6 and 7. The same laws of exponents can be used here when multiplying radicals. I'll show you some examples. While multiplying radicals, n value may be same, may be different. Number inside root sign also may be same, may be different, no matter. If they are same, if they are different, in all the cases we can multiply them together. Let's take different examples. First example, where n value will be same, but the number inside root sign will be different. What is this? Square root, right? Square root, because no number is visible, that means 2 is hidden. No number is visible in the V shape, so 2 by default is hidden. This is root 2 and we have to multiply this with root 3. Different numbers inside square root sign, n value same. To multiply, you write 2 times 3, that is root 6. Now I said laws of exponent. So where is laws of exponent? You might be thinking, sir, you said laws of exponent will be used, but you did not use laws of exponent. Let me show you how. See the explanation for it. Further explanation about this operation is this. Root 2 times root 3 means it is 2. I taught you in the previous page that suppose here it is n and here it is a raised to the power m. We write it like a raised to the power m by n. Can you tell me in this first one what is the m value? What we should write it? Write for it? 2 raised to the power 1 by 2, because root 2 means 2 raised to the power 1 and here it is 2. So 2 raised to the power 1 by 2. Power 1 is hidden here. Yes. Power 1 is hidden and number 2 is hidden in place of n, V shape. So 2 raised to the power 1 by n, 1 by 2. Is that okay?
Yes.
Similarly, root 3 means 3 raised to the power 1, 1 is hidden in the power and this 2 is hidden here in this place. So this is 3 raised to the power 1 by 2. I hope it's not a problem. Now multiply sign is between them. Using the laws of exponent says that if you have a and b different bases but with the same powers like power m on both of them, you have to multiply. Laws of exponent says to multiply the two bases together keeping the power same, like this.
Yes.
Right?
Yes.
I have the same situation. Different bases, powers same. So I'll multiply the two bases together, power will be same rule I applied here. Now it's going to be 6 raised to the power 1 by 2,
Yes, sir.
which further can be written as root 6.
Yes, sir. 1 by 2 equals
Done.
to root.
So this is the further explanation, deeper explanation of why it happened. Laws of exponent are applied here. I think it's more clear now.
Yes.
Okay. Well, so we took the example with the same n value. Now we are going to take the different n value this time. Number 2, different n value, like this one is a square root, and this one I am taking cube root, and I am taking the number inside the root sign same, like here 5 and here also 5, number same. Now I am multiplying, n value different but the number inside same. What do you think we can write for it?
30.
30, sure?
No, 5 root 5.
5 root 5, are you sure? Making guess, right?
Sir, I think it's 30 because we multiply root 2 and root 3 and root 5 and root 5 is 5. So 6 into 5 is 30.
Okay. Let us see it in more detail. Root 5 means 5 raised to the power 1 by 2, right? The second one is 5 raised to the power 1 by 3, right?
Yes.
Multiply sign between them. Which law of exponent is matching with the situation? Same base, different powers. A raised to the power m, a raised to the power n. Same base, different powers, and multiply sign between them says that a raised to the power m plus n can be written.
Yes.
So we can follow the rule. 5 raised to the power 1 by 2 plus 1 by 3, powers added together, base was same, so written once. Now 1 by 2, 2 plus 1 by 3, add them together. How much you get?
1 by
5 by 6. Shortcut, use shortcut I taught. 3 2 is 6, LCM. Don't take LCM, instead multiply. LCM is also 6 actually. 3 2 is 6. Cross multiply. 3 1 is 3, 2 1 is 2, 3 plus 2, 5.
5.
Now change it into root sign. Write it using root sign. So it will be like 5 raised to the power 5 under the 6th root. Isn't it? This is equal to this.
Yes.
Got it?
Yes.
Like if you have root sign a raised to the power m and n is here, you write it a raised to the power m by n. So you can do this reverse as well. I mean a raised to the power m by n. You can take a raised to the power m inside the root sign and n goes here outside. So I did this. This is the answer. 5 raised to the power 5 is 625, I guess.
Yes. Yes.
So this is 6th root of 625. And let me tell you, many students remain confused about this operation because they don't study it from this much basic way. Many students, I am not telling all, but many students, as per my experience, you can check it. I hope you got the way how to do it.
Yes.
Would you like to
Yes,
try?
sir.
Yes.
Sir, but root 5 and root 5 is 5, so why didn't we do it that?
But that is not root 5. This is cube root 5. This is square root 5. Okay, I'll show you. I'll show you why. See, you said root 5 and root 5. Of course, it is 5. I agree with you. But see what the way says. This is equal to 5 raised to the power 1 by 2. This is equal to 5 raised to the power 1 by 2. Same base, same powers. You will add the powers together. So 5 raised to the power half plus half. Half plus half. 1. That is 5. This is how 5 comes. Got the way?
Yes.
But in shortcut, you remember root 5 into root 5 is root 25, that is 5. Root 25, that is 5. You can remember in a short way that, but this is the more detailed way. Why it becomes 1, I mean in the power. Why it becomes 5 raised to the power 1 or 5. This is the logic. Got it?
Okay.
Okay, try once. Try a question I am giving. Simplify root 6 times cube root of 5 square. Try this and submit your answer.
Yes.
Are you done?
I think the question is done.
Question is? I couldn't get it. Please repeat.
I think like what is the question is the answer.
Question itself is the
We
answer.
can't use the because we can't use any laws of exponent in this
Hmm.
because we have the base different and the powers are all.
I understood. I understood your point, and I appreciate your effort. Can you tell me what is the last step you got? What is there in the last step you got?
6 to the power 1 by 2 into 5 raised to the power 2.
Okay, you are here, right?
Yes.
And now you are thinking the bases are not same, powers are not same, so no laws are getting applied. Correct?
Yes.
Okay. I appreciate you reached there at least, but there is a way to move ahead of it. See how. Root 6 into cube root of 5 square means 6 raised to the power 1 by 2 times 5 raised to the power 2 by 3. Neither bases are same nor powers are same, both are different, but we can do one thing. What? We can make their denominators same. How so? When you were in grade 7, you might have studied equivalent fractions. Do you remember?
Yes.
Okay. And what is the LCM of 2 and 3?
6.
6. So let's try to make their denominators same. In the first one, 6 raised to the power 1 by 2 times 3 by 3. Is there any problem doing this? I mean, is this valid to do? I'm talking about the validity.
First we'll take the LCM and then we'll cross multiply.
No, wait. We are not adding them.
Oh, yes.
We are not adding them. You thought we are adding them. That's why you are telling that. We are not adding them presently. We are making their denominators same using equivalent fraction method. So I am asking, is there any problem, do you think, in the validity? You can tell me, sir, if it is valid or not. If you have that question, you can tell me. In the second one, 5 raised to the power 2 by 3, I'll multiply with 2 by 2. Okay, let me answer if this is valid or not. If this is valid or not. Mathematically, if I multiply any number with 1, am I changing the number?
No, sir.
If I multiply any number with 1, did I change that number?
No, sir.
No. That means it's valid. If I multiply with 2 and change the number, then of course it is not valid. Someone can question on my work telling that the original number was 5 but I made it double. Why? But if I multiply with 1, no one can question on my work because I did not make any change. 3 by 3 is also 1. 2 by 2 is also 1. So I multiplied with 1. It's valid. I did not make any change. Well, so further it's going to be 6 raised to the power 3 by 6. And the second one is 5 raised to the power 4 by 6. I'm not going to simplify, remember. Well, I have multiplied and got this. If I simplify, if I cancel out, I'll get back to the previous step 1 by 2. I don't want to go back. I want to go ahead. Now their denominators are same. So there is a law of exponent which says that if you have power to the power, n, one power over another power. Have you seen this earlier?
Yes, sir.
What to do in this case?
M and N will be multiplied.
Exactly. The two powers gets multiplied. A raised to the power mn. So using this law of exponent, I can rewrite this as 6 raised to the power 3 and whole raised to the power 1 by 6. Is it valid?
Yes.
That's valid. Okay. Now this one is 5 raised to the power 4 and whole raised to the power 1 by 6. Again valid. Now we have powers same. Base is not same but powers same. Right?
Yes.
Good. So 6 raised to the power 3 and 5 raised to the power 4. 5 raised to the power 4 is 625 and 6 raised to the power 3 is 216. What if we multiply these two numbers? Let us multiply these two numbers. I want a quicker response on it, so I am using it. 625 times 216, 135 000. So it's a, now laws of exponent for this situation is this: base is not same, powers same. Base is not same, powers same. Multiply sign between. So a b raised to the power m. I can multiply the bases together. 6 raised to the power 3 into 5 raised to the power 4 and power together. Is it valid?
Yes, sir.
Now if I multiply these two numbers as I have done here, 135,000 raised to the power 1 by 6. So it is further sixth root of 135,000. Answer. This is equal to this. So this was a case when we have neither bases same nor powers same. In that case, we can move ahead using equivalent fraction method,
Okay.
making their denominators same. Okay, now we have to stop here only in this class. I'll send you some questions of this type for your homework. I hope you have enjoyed the class.
Yes.
Okay, so bye bye for now. See you in the next class.
Bye.